Hello everyone, welcome to our channel Off Campus. Before going into the video, kindly subscribe our channel Off Campus and then click on the bell icon also. Then only you will receive notification whenever we upload videos. In this video, we are going to discuss about some previous year gate problems in control systems. Okay, this will be helpful for our upcoming competitive exams like tneb and TRB Polytechnic exam and all other competitive exams as well. Okay, let's go into the video. Assuming zero initial conditions, the response y of t of the system given below. So response is given below. See the block diagram. To a unit step input u of t is. So y of s is given. We need to find out what is that? The response y of t we are going to find out. So see u of s 1 by s into y of s. So y of s is nothing but that's the multiplication. 1 by s into u of s. So u of s is, we know that 1 by s, unit step input in t domain. So 1 for t greater than 0, 0 for otherwise. Okay. So see. So u of s, Laplace transform of u of t is nothing but u of s is equal to 1 by s. See. So 1 by s into 1 by s, 1 by s square. Now we are going to taking inverse Laplace transform y of t. Y of t 1 by s squared is nothing but t into u of t. So what is that? Option B, t into u of t is the right option. Then the next problem, see. Consider the following block diagram in the figure. Consider this block diagram. The transfer function c of s by r of s we are going to find out. We'll see. So 4 different options are given. We are going to find out. I am just redrawn the circuit given in the previous page. Okay, so this is the circuit given. Now we are going to eliminate the going to reduce the block diagram. So r of s means r will go here, right? Or the same r will go here and the same this r will go here and this here also r will go. Okay, then what will happen? This is a summing point. So r into g1, here r g1, here r. So rg1 plus r into g2, right? So r into g1, rg1. Output of this block is rg1. Here r, this r. Okay, both are addition. So just add rg1 plus r here into g2. Output of here. Okay. Then this will be summed up with one more r here. So rg1 plus r into g2 plus r. So c of s is equal to this one, rg1 plus r plus into g2 plus r. So c of s. In short, I will write as r here instead of writing r of s. Okay. Then multiply inside rg1 g2 plus rg2 plus r. So take r common outside, r of s, g1 g2 plus g2 plus 1. Then what is c of s? Because we need to find out c of s by r of s. So now what is c of s divided by r of s is nothing but g1 g2 plus g2 plus 1. So option C is the right option. Okay. Then the transfer function y of s by r of s of the system is shown. So we need to find out the transfer function of y of s and r of s. This is also block diagram reduction of block diagram. Okay. So just read on again the given. Okay. So here see plus minus, here summation, all this. Okay. See r of s summed up with some value. Some value we don't know. Okay. Here see r of s is summed up with some value. This output we do not know, right? So take it as x of s. Okay, take it as x of s. So what will happen? X of s. So r of s minus x of s is nothing but some value, take as e of s. Okay, after summing we will get e of s. Take it as. So this e of s go here. Okay, then what will be the output here? E of s into 1 by s plus 1 into e of. So 1 by s plus 1 into e of s we will get here. Okay. Then in above block, see e of s into 1 by s plus 1. Okay. Now we are going to summing. This is plus, this is minus, nothing but subtraction. So the same term, see here also this is plus minus get cancelled, we will get 0. So what is actually x of s? X of s we have taken here as x of s now because we don't know the value. Previously we don't know the value, what is the output, so we just take this is x of s. Now we know what is the output of this, 0. So 0. So 0. So what we will get? So see, this is the output y of s. What is y of s now? Take x of s is equal to 0, let it be. Then what is y of s? So because what we need to find out, y of s by r of s. See, what is here? Y of s is equal to 1 by s plus 1 into e of s, this value. Now e of s is nothing but what? R of s minus x of s, right? So what is x of s? X of s is equal to 0. So then what will happen? E of s is equal to r of s. So instead of e of s, we can substitute as r of s here. Okay. So we need to find out y of s by r of s only now. So y of s by r of s is nothing but 1 by s plus 1. The same term. What is given in the block will transfer function is also same. 1 by s plus 1 is the right option. Then by performing cascading and or summing differencing operation. So and summing or summing and differencing operation using transfer function blocks g1 of s and g2 of s, one cannot realize a transfer function of the form. So 4 different options are given. We are going to identify now which one cannot be realized using that, which transfer function cannot be realized using that and or summing or differencing operations. Okay, see, g1 of s, g2 of s we can find out, right? Because see, from the options only we are going to identify. So by cascading to here g1 of s and connecting one more block as g2 of s, what will be the output? G1 into g2. So again g1 of s divided by g2 of s. Division only we cannot realize because division we don't know any option. So addition, here addition and multiplication we can realize. Here subtraction and multiplication also we can. So addition, subtraction, multiplication, all the operation we can realize, but g1 of s by g2 of s division we cannot realize. So this is the answer. Then given a matrix is given, the state transition matrix A of t is given by. So we need to find out the state transition matrix. So what is the formula? State transition matrix STM is nothing but e power at is equal to phi of t. What is the formula? Laplace inverse of Si minus A the whole inverse. So this is very important state transition matrix. That is a one question for sure for any exam. Okay. So Laplace inverse of Si minus A inverse. So find out Si minus A, then find out the inverse of this. After taking all this, we need to take the inverse Laplace transform of that. Okay. So first we'll find out Si minus A. So what is Si? What is I actually? I is a unity matrix. So given matrix is 2 cross 2. A is also given as 1 0 0 1. 2 cross 2 matrix now. So I is also unity matrix. What is a unit matrix? 1 0 0 1. Okay. This is I. What is Si? Just multiply each and every element with S. So this is Si. Okay. This is Si matrix. So S into S 0 0 S 1 0 0 1. So just a multiplication of this S matrix S 0 0 S with 1 0 0 1. Okay. Then we will get S 0 0 S minus A. What is A given? 1 0 0 1. Here 1 0 0 1. So just take a normal subtraction Si minus S minus 1. Here 0 0 S minus 1. So Si minus A. Then we'll find out Si minus A the whole inverse. So what is the inverse matrix? What is the formula? A inverse is nothing but adjoint of A divided by modulus of A. Similarly, we are going to find out for this. So Si minus A inverse nothing but adjoint of this one and the magnitude of this one. Okay. So adjoint of this one for what is the shortcut for to find out? So see, if matrix A is let it be, or matrix X, say it is a matrix X, what is the term? A, B, C, D, okay, 2 cross 2. So what is adjoint of X? In short, so just transpose these two, okay, D, A, and then change the sign of these two. If it is positive, change to negative. If it is negative, change to positive. Minus B, minus C. So this is the procedure to find out the adjoint of any matrix, okay, adjoint of any 2 cross 2 matrix. So D, A, just interchange this diagonal element. For this diagonal element, just change out the sign. For any sign, we are going to change to its opposite sign, okay. So for adjoint of A, adjoint of this one divided by modulus. So adjoint of this, just a transpose, we will get the same value only, okay. Then changing negative sign, both are 0 only, so much not it will not impact, okay. So 0 0, so simply s minus 1 0 0 minus 0 s minus 1. So then what is the magnitude of this one? Then see s again just repeat the numerator. Then what is in the magnitude? Magnitude is finding out s minus a the whole square, s minus 1 the whole square minus 0, we will get s minus 1 the whole square. So here divide by this value by each and every element in the matrix, inside the matrix, okay. So si minus 1 divided by this. So 1 can get cancelled, so 1 by s minus 1 0 0 1 by s minus 1. So this is si minus a the whole inverse. Now we are going to take inverse Laplace transform. Laplace inverse of this, what we will get? 1 by s minus 1, what is? E power t. E power 1t, we will get 1 by s minus 1. Again 0 for 0 0 0. Here again e power t, okay. So this is the answer. So whenever given to given to find out the state transition matrix, this is the formula, Laplace inverse of si minus a the whole inverse. We know this, there is no doubt, we can solve very easily. So this is the answer. Then moving on to the next, the unit step response of a system starting from rest is given by c of t is equal to 1 minus e power minus 2t. For t greater than or equal to 0, the transfer function of the system is. So what is given? Unit step response of the system is given. The transfer function we are going to find out, we'll see. So transfer function is nothing but c of s by r of s. So what is given? C of t value given. This is the output response. And what is the input? Unit step response. So r of t is nothing but u of t, okay. So c of t value is given, r of t input is step input. Step input is nothing but r of t is equal to u of t. We need to find out the transfer function c of s by r of s. Just find out the Laplace transform of this c of s for 1. What is the Laplace transform? For 1 unit step input 1 by s, then minus e power minus 2t 1 by s plus 2, okay. Previously we have solved Laplace transform and properties and problems, okay. If you haven't seen those videos still, kindly check with the playlist, it will be in the under engineering mathematics playlist, okay. Then r of s is nothing but 1 by s. So now what we are going to find out? C of s by r of s. So C of s by r of s. So C of s is this one divided by r of s 1 by s. So take LCM in the numerator. So s into s plus 2, here s plus 2 minus s, this and this get cancels, 2 by s into s plus 2. Then this will go to the numerator, okay, 2s divided by s into s plus s and s get cancelled. What will be the C of s by r of s? 2 by s plus 2 is the answer. So option 2, B is the right option. Then one second guys, for the second order closed loop system shown in the figure, the natural frequency in radians per second we are going to find out. So in this figure what is given? The second order closed loop transfer function is given. So this is g of s, this is h of s. H of s is not given anything now, we can take it as unity feedback. Okay, if at all any not given anything now, we can take it as a unity feedback. So h of s is equal to 1. Okay, so we are going to find out natural frequency. Natural frequency is nothing but omega n. So first find out the transfer function of this closed loop transfer function and then equate it to the standard second order closed loop transfer function. What is that standard transfer function of second order closed loop transfer function? Is nothing but omega n squared plus s squared equal to zeta omega ns plus omega n squared. So from the block we are going to find out the closed loop transfer function and then equate this to the standard second order closed loop transfer function. Then we can find out the omega n value, that is natural frequency, which is in radians per second unit. Okay, so as I told earlier, whenever or not it is given any feedback value, we can take it as unity feedback. H of s is equal to 1. What is a closed loop transfer function? G of s divided by 1 plus g of s h of s. G divided by 1 plus gh. So again, see, substitute h equal to 1, we will get g by 1 by g. Okay, what is g? 4 by s into s plus 4. So see, we can substitute this also, 4 by s into s plus 4 divided by 1 plus 4 by s into s plus 4. So then take LCM and then solve. It will take time. Whenever see it is a unit step input, we can say it as a what is a closed loop transfer function. Whenever given feedback is unity, means what is the closed loop transfer function? Y of s by u of s is nothing but just add the numerator term in the denominator. Okay, 4 divided by s into s plus 4 plus 4. So this is a shortcut, or you can apply the standard formula and we'll find out. See, we'll check it. Okay, applied now. So 4s plus 4, here also in take LCM, s into s plus 4 plus 4, here taking LCM in denominator s into s plus 4. So see, these and this get cancelled. What is remaining? 4 into s plus 4 plus 4. So 4 into s plus 4, s into s plus 4 plus 4, this one. Okay, so in short we can write it. Whenever unity feedback means no need to solve for the closed loop transfer function using this formula, just add the numerator term in the denominator. Okay, just add 4 into s plus 4, just write, then add the numerator term in the denominator. It's far enough. Okay, now multiply inside, s squared plus 4s plus 4. So what is the standard second order transfer function of closed loop, okay, system? So omega n squared divided by s squared 2 zeta omega ns plus omega n squared. So now what we need to find out omega n value. Just compare this equation with the standard second order transfer function. So omega n squared is equal to 2. What is omega n? Omega n is equal to 2 radians per second. So answer is true. Then, so given f of t value given, Laplace inverse of some transfer function given, some value given. So if limit t tends to infinity, f of t is equal to 1, then the value of k is. So what is given? This is the limit. This is the final value theorem of Laplace. As I told earlier, we have discussed about Laplace transform properties and inverse Laplace transform, and also final value and initial value theorem of Laplace transform. So that all the basics. Okay, without knowing that we cannot solve the control system problems. Okay, if you haven't seen those videos still, kindly check with our playlist, previously solved problems under engineering mathematics. Okay, now so t tends to infinity is nothing but this is the final value theorem of Laplace transform. So what is the final value theorem of Laplace transform? Limit t tends to infinity, f of t is nothing but limit s tends to 0, s into f of s. This is the final value theorem of Laplace transform. So actually what is given? This value is equal to 1. Then we need to find out the k value from the given f of t. Okay, this is Laplace f of s value given. So f of s is equal to the given value, which is equal to, so this is limit t tends to f of t is nothing but limit s tends to 0, s into f of s. F of s is the given problem. So this one, that's just which is equal to 1. Okay, which is this is equal to this one, that is equal to 1, so equal to 1. So now we are going to take s outside from here, denominator. So s square plus 4s plus k minus 3. Okay, then s and s get cancelled, then substitute limit s tends to 0. So 0 we will, in numerator 1 will be remaining, in denominator this term 0, this term 0, simply k minus 3. So 1 by k minus 3 is equal to 1. Then what is 1? 1 is equal to k minus 3. What is k? 1 plus 3, 4. K value is 4. Okay, 4. Then if the closed loop transfer function of a control system is given as T of s is equal to s minus 5 into divided by s plus 2 into s plus 3, then it is, we are going to find out whether it is unstable or uncontrollable or minimum phase or non-minimum phase. Before going to solve this, we should know that what is a stable system, what is a controllable system, and what is a minimum phase system. Then only we are going to solve this problem. We will be able to solve this problem. So what is a stability? What is a stability condition? All the poles lie in the left half of S plane only. So this is depends only on the poles only. Stability condition means, what is the stability condition? All of the poles should lie in the left half of S plane. Say this is a S plane, this is sigma, this is j omega real axis, this is imaginary axis. So all the poles, this is a pole symbol, this is a 0 symbol. So all the poles should be in the left half of S plane only. No pole should be in the right half of. So this is a left of S plane, this is right of S plane, right? So all the poles should be in the left of S plane for the stability, for the system to be stable. So there is no condition for zeros. Zeros may be anywhere. So there is no, this depends only on the pole condition. Okay, pole location of poles. Stability of the system depends only on the location of poles. So this is the stability. From the transfer function we can check whether it is a stable or unstable, then we can solve. Next, what is uncontrollable system? Before knowing uncontrollable, we need to know what is controllable and observable. So whenever the system is stable, then it is said to be controllable and observable. Whenever system, so stability condition is far enough to find out whether the system is controllable or not. Okay, then what is the next one given in the option? Minimum, non-minimum. So first we know minimum phase system. So condition for minimum phase system is nothing but all the open loop poles and zeros should lie in the left half of S plane. See, here for stability there is no condition for zeros. So the location of zeros can be anywhere. It should depend only on the location of poles. Whereas minimum phase system, all open loop poles and zeros should lie in the left half of S plane only. Poles as well, 0 also. Okay, should be lie in the left half of S plane. Okay. So first we'll find out the, if it is all poles left half of S plane, 1 0 is right half of S plane, means then the system is non-minimum. So from this we'll find out the location of poles. We'll draw the location of poles. S plane, sigma j omega. So S equal to 5. This is 0 location. Then S equal to here. Numerator. So we should know how to find out the poles and zeros from the transfer function. So numerator terms equal to 0, we can find out the 0 location of 0. So denominator term represents the location of poles. Okay, so S minus 5 equal to 0. What is S? S equal to 5. So 0 location, 0 at plus 5. Okay, then here in denominator S equal to minus 2 comma minus 3, S plus 2 equal to 0, and S plus, this is pole location. So see, S equal to plus 5, see it is a plus 5. So there is a 0 at plus 5. then s equal to minus 2 minus 3. What is that? In denominator, this is a pole location, no? Minus 2 minus 3. This is a pole location. So, 2 poles in the left half of S plane, 1 0 in the right half of S plane. So, I will tell you again, numerator term, we can use the numerator term to find out the location of poles, zeros. Denominator term is used to find out the location of poles. Okay, numerator for zeros, denominator for poles. Okay, so equate numerator part equal to 0, s minus 5 equal to 0, s equal to 5. So there is 1 0 at s equal to plus 5. So here, then, so it is a 1 2 3 4 5 scale margin. Okay, then here denominator term represents the location of poles now. So s plus 2 equal to 0, s equal to minus 2, here s equal to, so at minus 2 and minus 3 we have 2 poles. Okay, so from this we are going to find out what is whether it is a stable or unstable system. So stability depends only on the location of poles. So this is left half of S plane, this is right half of X plane. Stability condition, no condition for zeros. So first we will see whether it is a stable or unstable system. So all the poles, see only the pole location, all poles in the left half of S plane only 1 0 in the right half of S plane. So stability includes only location of poles. So the system is stable now. Okay, the given system is a stable system. So option is unstable will not come. The system is stable. I said earlier, whenever system is stable, then it is controllable as well as observable. So this is also controllable system. So uncontrollable is also wrong. Stable and controllable system. The given system is stable and controllable. Then minimum phase. We will check for minimum phase. What is a minimum phase system? All open loop poles and 0 should lie in the left half of L. Poles as well, 0 should lie in the left half of S plane. So see, 2 poles only left half of S plane, 1 0 in the right half of S plane. So this is not a minimum phase system. This is a non-minimum phase system. So non-minimum phase system is the right option. Okay. From this question we can know all these conditions. What is stability, uncontrollable and observable, and what is minimum phase system, all. Okay. Then the transfer function V2 of S by V1 of S of the circuit shown below is. So we are going to find out V2 of S by V1 of S. Okay. So in short, V2 of S by V1 of S is nothing but, so first what is V1 of S? V1 of S is nothing but, say it is I of S. I of S current is flowing. This current is flowing through this. What is V1 of S? I of S into capacitor can be represented by 1 by SC in S domain, and SC, SL for inductor. Inductor can be represented as SL, or resistor will be represented as simply R only. Okay, we should know all this. So this is in the S domain now. So I of S into 1 by SC flow. So see, I of S flowing through this one. Okay, this is this closed loop system, this closed circuit. So V1 of S is equal to I of S into 1 by SC plus R plus 1 by SC. So C plus R plus C. Okay, 1 by SC plus R plus 1 by SC. So what is V2 of S? V2 of S is nothing but flowing through this one. So I of S into R plus 1 by SC, right? So this one. Now what we need to V2 by V1. So V2 by V1 is nothing but this by this division. So this and this get cancelled. So just taking LCM. SCR 1 plus SCR divided by SC. Here also SC plus 1 plus SCR plus 1. Okay. So 1 plus SCR divided by 1 plus 1, 2 plus SCR. Okay. So this is the transfer function V2 by V1. Now we are going to substitute the values of RC. Okay. What is the C value? 100 microfarad. R value 10 kilo ohm. So what is RC? 10 kilo ohm into 100 microfarad. Here see, this is 10 kilo ohm, 10 power 4, 100, 10 squared, microfarad, 10 cube. This is 10 cube, already 110, so 10 power 4. This is 10 squared. For micro, we can take it as 10 power minus 6. So, adding power, all power, 4 plus 2, 6, 6 minus 6, 0. 10 power 0 is nothing but 1. So, RC value is 1. Just substitute RC value as 1. So, 1 plus S divided by 2 plus S, or we can write it as S plus 1 by S plus 2. Okay. So, option this one, S plus 1 by S plus 2, option D. Okay, we'll move on to the next problem. For the following block diagram, x1 of s is equal to 0, the transfer function y of s by x2 of s. So, what is given? x1 of s is 0. If it is 0, we need to find out y of s by x2 of s. We'll see. So, if it is 0 means what will happen? x1 of s is 0 means adding with for anything, it can be anything now. For any value will come. Say it is a x3 or some y is also some z of s value, let it be. Okay, some z value, some any value, we are going to subtract from plus minus. So, will not going to impact. So, whatever will come will go to this only. Okay, this is 0. So, we can omit this. Okay, this will go here. So, similarly this one, this will go here. Then redraw the circuit. Plus, here also plus, this minus will come, right? Here minus sign, minus of this value, whatever will come, minus of this value plus 0. So, it is 0, we will omit this. So, this one minus of this, then plus x2 of s into 1 by of s into y of s. Okay, can you understand, guys? Now, we are going to switching the blocks. Okay, so this sum plus minus only now, this plus minus, this minus value will go here. Okay, so plus minus, this will become plus minus. Okay, this minus will become here. So, this is x2 of s, we are going to switch these two. So, x2 of s, this minus value, this block we added with this 1 by of s, then here this block. Okay, okay, see, this is multiplied by minus sign, minus s by s plus 1. In clear, I will explain. So, minus s into s plus 1. So, we are going to this summation point, switch here, then this block will go here, right? This summation point. Okay, adding this, just direction only differ. Okay, then this is g of s, this is h of s. What is y of s by x2 of s? G divided by 1 plus gh. So, what is g? 1 by s. What is h? S by s plus 1. Just substitute in this formula. 1 by s plus 1 by s into by, in short we will take LCM and simplify. What we will get? S plus 1 divided by s into s plus 2. Okay. For that, what we need to know, this just omit this block, then switch this and take this as a feedback loop. We will resolve. Take this as a g and this as a h. Then what is formula? G divided by 1 plus gh. By substituting this, we can find out the answer. Then the Laplace transform of I of t is given by I of s is equal to 2 by s into 1 plus s. As t tends to 0, t tends to infinity, the value of I of t tends to, what is given? I of s value given. As t tends to infinity, we are going to infinity means steady state value or final value. What is the final value theorem of Laplace transform? limit t tends to infinity. At t tends to infinity, we are going to find out I of t value at t tends to infinity. So limit t tends to infinity, I of t in general, what is the final value theorem? Limit t tends to infinity, f of t is equal to limit s tends to 0, s into f of s. So limit s tends to 0, s into f of s. F of s nothing but I of t, I of s 2 by s into 1 plus s. So 2 by s into 1 plus s. Here s and s get cancelled. Now substitute limit s tends to 0 here. So this term will get cancelled. So 2 by 1 we will get 2. So at t equal to infinity, I of t value at t tends to infinity is nothing but 2. Then the steady state error of the system shown in the figure for a unit step input is. So for this system we are going to find out steady state error of a system. So for unit steps input, what is the formula to find out the steady state error is nothing but ESS equal to, for unit step, 1 divided by 1 plus Kp. Okay, what is Kp? Positional error coefficient. So what is positional error coefficient? Kp is nothing but limit s tends to 0, g of s into h of s. Okay, so first we'll find out the Kp value, then we'll find out the ESS, steady state error for unit step input. So see, Kp is nothing but g of s into h of s. So this is h of s value, so this is g of s value. G of s, these two in cascade connection, so just it is a constant multiplication of these two we will get. So what is G of s? 4 divided by s plus 2. 4 into 1 by s plus 2 we will get 4 divided by s plus 2. So this is G of s, this is h of s. Just substitute in this formula, limit s tends to 0. So in short, so cascade connection, cascade, so just a multiplication. Okay, then g of s value this is h of s, then limit s tends to 0 into g of s into h of s. Now substitute 0 in place of s. What we get? 4 by 2 into 2 by 4, right? 2 get cancelled, all get cancelled, Kp value 1. Now what is the steady state error formula? 1 by 1 plus Kp. 1 by 1 plus Kp is equal to 1 by 1 plus 1, 1 by 2. Then, despite the presence of negative feedback control systems, still have problems of instability because the 4 different options are given. So what is the best option? Components used to have non-linearities. Components used to have non-linearities is the right option. Then a linear system is described by the following state equation: x dot of t is equal to a x of t plus b u of t. A matrix is given, state transition matrix of the system we are going to find out. So already we have seen one problem based on this type, state transition matrix STM. So what is the formula? Phi of t is equal to Laplace inverse of Si minus A, the whole inverse is equal to STM. What is Si minus A? Si is nothing but S0, 0, S minus A. A is the given matrix. So 0, 1, minus 1. So just subtraction S, here minus 1, here minus plus 1, here S only. So this is Si. Then what is Si minus A, the whole inverse? Adjoint of this divided by modulus of this. Adjoint of this, how can we find out? Just interchange these two. Whenever interchanging the same element only, so S, change the sign of these two diagonal elements. So minus 1 become plus 1, plus 1 becomes minus 1. Divided by magnitude of this, just take modulus value. So S squared minus of minus 1 plus 1, S squared plus 1. So now we are going to divide by this term inside the matrix. Okay, so S squared plus 1 can be written as 1 squared. Okay, S by S squared plus 1 squared, this is 1 by S squared plus 1 squared, this is minus 1 by S squared plus 1 squared here. This is plus S by S square plus 1 square. Now what we need to take? We need to take Laplace inverse Laplace transform. So Laplace inverse of this term only na. So taking inverse Laplace transform, this is cos t. So what is cos omega t in general? Laplace transform of cos omega t s divided by s square plus omega square. Then what is sin omega t? Omega divided by s square plus omega square. Okay. So s divided by s square plus omega square cos t. What is omega value? 1 only. So simply cos t. Then 1 divided by s square plus 1 square sin t. Again minus sign will be in the outside. So it is sin t. This is cos t. So cos t sin t minus sin t cos t. So this is the STM value. Which one? Cos t sin t minus sin t cos t. This one, option A. Then we'll move on to the next one. A unity feedback system has an open loop transfer function g of s value given, the gain k for the system to have a damping ratio 0.25. So what we are going to find out? The k value we are going to find out. What is given? Damping ratio value given. Damping ratio is nothing but zeta. Okay. So we know that standard second order general second order closed loop transfer function is nothing but omega n square divided by s square plus omega 2 zeta omega ns plus omega n square. So what is the closed? So this is open loop transfer function g of s, and what is given? Unity negative feedback system is given. So h of s is equal to 1. This is a standard g divided by 1 plus gh. So g of s value is given in the problem. Okay, what is h of s? Unity negative feedback is nothing but h of s is a unity feedback. I told no previously, whenever feedback is unity, how can we solve? Rather applying in this formula, what is the shortcut? Just add the numerator term into the denominator. So k divided by s into s plus 10 plus k. So here whenever unity feedback system, we can just add numerator term into the denominator. So k divided by, multiply inside with s squared plus 10s plus k. So just equate with the standard closed loop transfer function. Okay, this term. So now one more term is given. Damping ratio is nothing but zeta. Zeta value is 0.25 is given. We are going to find out the k value. So zeta value given. So 2 zeta omega n is equal to 10. Just substitute zeta value as 0.25. 2 into 0.25, what we will get? 2 into 0.25, omega n is nothing but, this is 5. Okay, 10 by 0.5. This is 0.5, right? 2 into 0.25, 0.5. 10 by 0.5, we will get 20. Omega n value is 20. So what we need to find out? K value. K is nothing but omega n squared. Okay, omega n squared. So omega n is 20. What is omega n squared? 20 squared, we will get 400. So k value is nothing but 400. Then step responses of a set of 3 second order underdamped system all have the same percentage overshoot. So what is given? Step response of the set of a 3 second order underdamped system all have the same percentage overshoot. Which of the following represents the poles of 3 system? For 3 system they are giving, what is given? Will have the same percentage overshoot. Okay, we are going to have percentage overshoot for which system? Underdamped system, having the same percentage overshoot for underdamped system for 3 system. So we are going to find out which represents the poles of that 3 system. So which one has same percentage overshoot? From this diagram we are going to find out. Okay, so these are the 4 options. So first of all, what is the percentage overshoot? MP is equal to e power minus pi zeta divided by square root of 1 minus zeta squared into 100. This is the percentage overshoot. Okay, here MP, percentage overshoot, directly proportional to zeta value. So zeta, what is the Now we are going to find out the from the theta value, angle value we are going to. So zeta is nothing but damping ratio. How can we relate a zeta with theta angle? Okay, cos theta is equal to zeta. This is one of the formula. So theta angle is nothing but theta equal to cos inverse of zeta. Angle theta can be represented by theta equal to cos inverse of zeta. So from the for same theta value percentage also, so these are all the directly proportional na. So this is also direct relation with zeta and this is a zeta value only. So I will write in here symbol zeta only, whatever. Okay, so MP directly related to theta. Okay, all are, so theta value also equal. What is given in the problem? Same percentage overshoot. So which means that same percentage overshoot for same zeta value, all are direct proportionally. That is equal to angle also same for the three system. So poles location given, from that we can find out the angle. So see, just join to find out the angle. What we will get for this pole location, we are getting 1 theta, theta 1. For this is varying na, for second system, for third system also varying. So for three system we are having three different angles. So what is what we can conclude from this? For same percentage overshoot, theta value is differing. So this will not correct. This is a wrong one. For this one also join with here, see, so this one. So for this 1 theta value, for this is a theta, for this is a theta. So theta 1, theta 2, theta 3 is differing. So this is also wrong. For this theta value also same for 3 system. Okay, so this is a pole location given, just join this. See, theta value for this, for this, the same theta value, no, right? Theta value is same for three different poles, three different systems. So same theta value means same percentage error. For this also, so this one is the wrong, correct only. This is the correct one because angle is same for three different poles. So here check, this is theta is differing for three poles. Okay, so this is also wrong, this is also wrong, this is also wrong, this one is correct. Option C is the right option for this. MP f of type for same maximum MP for all three, that is zeta is same for 3 because zeta is equal to cos theta, theta equal to cos inverse, same for 3. Angle should be also 3, same. Then move on to the next one. With initial condition x of 1 equal to 0.5, the solution of differential equation t dx by dt plus x equal to t is, okay, what is given? X of 1 equal to 0.5, which means that at t equal to at t equal to 1, what is x value? At t equal to 1, x equal to 0.5. So what is given? T dx by dt by plus x equal to. So we are going to find out the initial condition given, differential equation, solution of this differential equation we are going to find out. So we will solve. So first equation, in this equation multiply by dt. Whenever multiplying by dt, what we will get? Dt and dt get cancelled. So t dx plus x dt is equal to t dt. So this is nothing but differentiation of uv format, right? Differentiation of xt, t dx plus x dt. See, u dv plus v du, differentiation of uv format. So this is differentiation of xt. This can be written as differentiation of xt is equal to t dt. Now we are going to integrate on both sides. Whenever integration and differentiation get cancelled, then xt is equal to, integrating this, what we will get happen? T squared by 2 plus some constant. So this constant value we are going to find out from the initial condition given in the problem. So at t equal to 1, what is the x value? 0.5. So substitute t value as 1 and x value is 0.5, then find out the c value. 0.5 into 1 is equal to 1 value 1 by 2 plus c. So 1.5 into 1 0.5, 1 by 2 0.5. So this and this get cancelled, c value is 0. So xt is substitute here xt plus t squared by 2, this value is 0 only. So xt equal to t squared by 2. So what is x value? Just cancel this, x equal to t by 2. So this is the solution of the given differential equation with the initial condition also given, x equal to t by 2. Okay. Then the unilateral Laplace transform of f of t is this, the unilateral transform of t into f of t. So this is also one of the property of Laplace transform, multiplication by t. So what is the multiplication property? Multiplication of t, this is called as differentiation property of Laplace transform. So t into f of, so if f of t is equal to f of s, and t into f of t is nothing but minus d by ds of f of s. Actually whenever t power n into f of t is nothing but Laplace transform minus 1 power n d power n by ds power n into f of s. Okay. So this is t power 1. So minus 1 power 1 d by ds. Okay. Substitute n equal to 1. We can say it as a t into f of t is nothing but minus d by ds of f of s. So we are going to find out t into f of t value. Okay. F of s is given. Now t into f of t is nothing but d minus d by ds of f of s. So differentiating with respect to s in this f of s. So minus d by ds of the given f of s value in the problem. So just a normal u by v format, v du minus u dv divided by v squared. So minus sign outside. So v take it as a constant, then du is a constant. So is this 0 again minus u dv 1 dv. Substituting this, what we will get? The differentiating 2s plus 1, right? 2s plus 1. So this term multiply by 0, this term get 0 only. So minus into minus. So minus outside. So then minus of 2s plus 1. Okay. Minus will be in the outside. So minus into minus plus 2s plus 1 divided by, what is in the denominator? V squared, s squared plus s plus 1 the whole square. So this is the answer. So which one? Option D. Then a second order. Okay. This is the last problem in this session. We will end the session up to this problem. Okay. In our future videos, we will solve more problems in control systems. Okay. So a second order system has the transfer function given with r of t as a unit step function. The response of the c of t of the system is 5. So c of s is r of s is given, r of t value is given as unit step input is nothing but u of t. So we need to find out c of t. That's it from the given diagram. Okay. So 4 different options are given. We are going to find out from this. So c of s by r of s value is given 4 divided by s squared plus 4s plus 4. So omega n squared divided by s squared plus 2 zeta omega ns plus, this is a standard second order closed loop transfer function. Just equate this to find out the whether the damping of the system. From the damping of the system we can find out which system matched with the given transfer function. So damping ratio zeta value we should know. So from this omega n squared equal to 4, then what is omega n? 2 radians per second. Then we need to find out zeta value. From the zeta value only we are going to find out which damping. So from the damping condition we can identify the figure. From the figure which will be the correct one. So 2 zeta omega n is equal to 4. What is zeta value? Sorry, omega n value 2. Substitute 2 into 2, this and this get cancelled. So zeta equal to 1. So zeta equal to 1. So before we should know the damping condition for different zeta value. So zeta value is 0 means it is undamped. Zeta value is 1 means it is critically damped. Then zeta value is 0 to 1 between value 0 to 1 means this is under damped. Okay. Zeta value is greater than 1 means it is over damped system. So for this, what is the zeta value? Zeta value 1. Zeta value 1 means critically damped. So from the figure, find out for which it is critically damped. Zeta value is 1. So first option C, it is going up and then reducing. So zeta value between 0 to 1. Okay. It is under damped system. So it is not. So this is wrong. Then zeta value for this is from 0 to 1. So zeta value is 1. This is critically damped. So this is the right option. Let's see other options also. So this is undamped system. Zeta value is 0. Okay. Then for the 0 to 1, beyond that also it is going. Okay. So zeta value greater than 1. Okay. So it is over damped. This is under damped, undamped, critically damped, over damped. For this transfer function, what is the zeta value? Zeta value 1 means critically damped system. This one is a critically damped. So for this transfer function, this is the right option. Option B. Okay. So we'll end the video up to this. So kindly stay tuned to our channel Off Campus and then subscribe the Off Campus channel and click on the bell icon also. Thanks for watching.